Hello, my dear friends. Welcome in science class. We are in chapter number 10, that is gravitation. In last lecture, we have seen comparison between mass and weight of object on moon, and some other important points. Let's quickly recapitulate our previous lesson topic, or say previous lecture topic. Let's quickly see comparison between mass and weight. We have one figure here, that is comparison of mass and weight. First point, mass is property of matter, and now we know that mass is same everywhere. Everywhere means everywhere in universe. Weight is not same on every place, that is dependent on gravitational acceleration of that particular place. Second point, mass can never be zero, whereas weight can be zero if there is no gravitational force are there. Third point, mass does not change according to location, that is same as our first point, whereas weight can increase or decrease according to higher or lower gravity. Mass is a scalar quantity while weight is vector quantity. Why? Because weight is nothing but force, and force is vector quantity, hence weight is also vector quantity. Mass may be measured using ordinary balance. Mass can be measured by using ordinary balance, while weight is measured using spring balance. Weight is measured using spring balance. I hope you know what is spring balance, or you may see in this spring balance sometimes at the delivery of our LPG gas cylinder. Mass usually measured in grams and kilograms, whereas weight measures in Newton, because unit SI unit of weight is Newton, because SI unit of force is Newton. After that, we have seen comparison of weight on moon and earth. In that we conclude that Wm divide We is equal to 1 upon 6, which means weight of object on moon is sixth time its weight on earth. In that I give you one example. If we feel weight of any object, say 6 Newton on earth, it will be weighing 1 Newton on moon. So that's the application of this concept. Now we have very important and interesting concept called thrust and pressure. Thrust and pressure. Let's read it, and by reading we can understand what is thrust and pressure. Have you ever wondered why a camel can run in a desert easily? Camel can run in desert easily. We know that there is a sand which is loosely packed in desert. In that desert, it is difficult to run on that surface, but camel can do it easily. And why an army tank weighing more than 1,000 tons rests upon a continuous chain? We see in the tanker in army, or this tanker are rest on chain kind of structure. There is a not wheel, it has chain kind of structure. chain and sprocket structure. Why a truck or a motor bus has much wider wheel? We observe that in truck and motor bus we have wide wheels. Why cutting tools have a sharp edge? Cutting tools have a sharp edge. In order to address this question and understand the phenomena involved, it helps to introduce a concept of net force, that is perpendicular to direction, that is thrust, which means the force, which means the thrust is force, and force per unit area is pressure. Remember, thrust is force and the force per unit area is pressure. So that is the comparison of thrust and pressure. Let's try to understand the meaning of thrust and pressure by considering the following situation. We look another example before dive into this textbook example. Say I have this pencil. It has sharpened edge one end and it is a blunt edge at other end. Let's I hold this pencil in my hand in such a way that this sharp point is in my finger side and this blunt edge is on thumb side. And now I applying pressure, same pressure on my thumb and on my finger. Let's hold this pen for few seconds. Now after holding this pen for few seconds, we can see depression here. You can see the depression here and here. Without showing this, you can answer my question. What do you think? Where will be more depression? More depression will be on finger or on thumb. You can easily say that more depression will be on finger. Why? I apply same force on thumb and finger. Despite of same force, there will be more depression on finger and less depression on thumb. Why? Because there is a less area in this pointed region and there are more area in this blunt region. You can see here the area is very less. Because the area is very less, pressure will be more, pressure will be higher. What is pressure? Pressure is force per unit area, which means pressure P is equal to F divide A, force upon area, by which now you can understood pressure is directly proportional to force and inversely proportional to area, which means if area will decrease, pressure will increase. If area will increase, pressure will decrease. So despite of same force, here I have very less area. So the pressure was very high and that's why this depression was more. And here the area is comparatively larger. That's why the pressure will be lower. So here I have less depression. I hope you could understood the example of pressure by this example we have taken here of pencils pointed end and blunt end. So let's take situation 1. You wish to fix a poster on a bulletin board. Now we wish to fix a poster on bulletin board. We can see here a picture of a boy is fixing a poster on bulletin board. To do this task, you will have to press drawing pins with your thumb. What we have to do? We have to push this drawing pin with our thumb. We have to push this drawing pin with our thumb, you apply a force on a surface area of head of the pin. You can consider this pencil as pin only, no? Because this area is larger and this pointed area is sharper and smaller. We apply force here. We apply force here. Here the area is large. Force is same. I applying the same force. This force, same force will be transferred here. This same force will be transferred here. But at this point I have very less area. So the whole force is pointed at this much area only. So that's why it creates larger pressure. So you apply a force on the surface area of head of the pin. This force is directed perpendicular to the surface area of board. This force acts on perpendicular area of board. We have to remember that in pressure there is a formula force divide area, but we should notice that and consider that this force should be perpendicular force apply on area. Perpendicular force apply on area. In your higher standard, you will learn about component of force. You will learn about component of force. Let me give you some hint. If I apply force like this, I am applying force like this. This pen is at certain angle. This pen is at time at certain angle. So I have two component of this force. One is this vertical component and this other is horizontal component. So in pressure, while calculating pressure, we consider only vertical force, that is perpendicular force applied to surface. So we have to remember this particular kind of force, that is acting in perpendicular to surface. This force is directed perpendicular to surface area of the board. This force acts on a smaller area at the tip of the pin, as we discussed earlier. Situation 2. You stand on a loose sand. Your feet go deep into the sand. If we are stand on loose sand, what will happen? Our feet go into deeper into sand. Now, if we lie down on the sand, what will happen? Will our whole body dipped at same rate as earlier? No, it will not. You will find that your body will not go that deep in the sand as our feet goes into the sand. If in both cases force exerted on the sand is weight of your body. I hope you can understood this. In both the case, which both the case? We are standing on sand or we are lying on sand. Force is same because our mass is same and gravitational acceleration at that particular place is same. So in standing position or in lying position, force exerted by us on earth or say sand is same. But penetration will be larger in first case and penetration in second case will be comparatively lower. So why it is happened? Because remember the formula of pressure. Pressure P is equal to force or say perpendicular force divide area. So force is same. When I am standing on the sand, the area will this much only. The area will this much only. That is less area. So area is less. So pressure will be large. So I will go more deeper into the sand. When I lay down on the sand, area will be this much. Area will be this much, larger area. So the area is larger, pressure will be lower. So I go deep into the sand, but as not as much deep in I go that in first case. So we have this situation, and now I hope you can understand what is the phenomena of pressure. You have learned that weight is a force acting vertically downward. We have learned that weight is the force acting vertically downward. In last lecture, we have discussed weight is force and direction of this force is vertically downward only. Here the force is acting perpendicular to the surface of sand. The force acting on object perpendicular to the surface is called thrust. We have definition of thrust here. You should mark this definition and note down in your notebook. The force acting on an object perpendicular to surface is called thrust. So the thrust is nothing but the force which is directed in perpendicular direction. So the thrust is force acting perpendicular to the surface. When you when you stand on loose sand, the force, that is weight of your body, is acting an area equal to area of your feet. As we discussed earlier, when you lie down, the same force act on an area equal to contact area of your whole body. In second case, we have area is larger area, that is contact area of our body. Remember contact area. If I lie down in this way, the contact area is only this and this. This area is non-contacted area, and this will not contribute to the particular area we required. So the necessary area is only this and this. I hope you can understood what is contact area, which is larger than the area of your foot. Thus, the effect of force of same magnitude on the different area are different. Again, the effect of force of same magnitude on different area are different. What is the effect of force, same force and different area? That is nothing but pressure. That is nothing but the pressure. For the same force, we can have less pressure or more pressure, that is depending on contact area. In above case, thrust is same. Thrust is same because force is same, because weight is same. So thrust is same. But effect are different. Therefore, the effect of thrust depend on area on which it acts. Therefore, the effect of thrust depend on area which it acts. So the effect, that is pressure, is depend on area. The effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called pressure. As we have discussed earlier, thrust on unit area is called pressure, or we can say that perpendicular force per unit area is called pressure. So you have to note down this and mark it. The thrust on unit area is called pressure, and the formula of pressure is pressure is equal to thrust divide area. Pressure is equal to thrust divide area. Now we know that as we derived a new quantity, we will find its SI unit, and we discussed earlier we need not mug up all this SI unit. If we remember few SI unit of basic quantity, we can derive by ourselves SI unit of other dependent quantity. Let's try to derive unit of pressure. Pressure is equal to thrust upon area. And now we know that thrust is nothing but force. So tell me the unit SI unit of force, that is Newton, divide area. What is the SI unit of area? SI unit of area is meter square. SI unit of area is meter square. So we have Newton per meter square as SI unit of pressure. We have Newton per meter square as SI unit of pressure. So substituting the SI unit of thrust and area in equation number 10.20, we get SI unit of pressure as Newton per meter square, or say Newton meter raised to minus 2. In honor of scientist Blaise Pascal, the SI unit of pressure is called Pascal. We have to remember this name, Blaise Pascal, because SI unit of pressure is Pascal, and we denote Pascal by capital P small a. Remember, capital P small a. Whenever we define unit by a single letter, we define it in capital letter. And when we use two letters, we denote it as first letter as capital and second as lowercase. So we have unit of Pascal, unit of pressure as Pascal, and denote by PA, capital P small a. 1 Pascal is equal to 1 Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. So we understood what is thrust, what is pressure, formula of pressure, and SI unit of pressure. Now we have pressure in fluids. Pressure in fluids. We know pressure now. What is fluids? Fluids, which is things that can flow. That can flow. Liquid can flow and gases can also flow. So we have to remember all liquids and gases are fluids. Remember, fluids are not just only liquids. It includes liquid and gases both. So all liquids and gases are fluids because both liquids and gases can flow. A solid exerts a pressure on a surface due to its weight. Solid can exert pressure on surface due to its weight. Similarly, fluids have weight. Fluids have weight. We know that fluids have weight because if I carry empty bottle, I have mass of this plastic bottle only. But if I fill it with water and if I carry after that, I can feel more mass, more weight because the fluid, that is a water containing in this bottle, will exert force. It has mass, so it has weight. So fluid have weight and they also exert pressure on base and wall of container in which they are enclosed. Remember, fluid exert pressure on base as well as wall. What is base of this bottle? Base of this bottle is this. This is the base of this bottle or its container. This is a container, no? So this is the base of this container and this surface is wall of this container. This surface is wall of this container, and liquid filled in this container will apply force on downward direction, that is on base, and as well as on its surface, that is its wall also. So we have the sentence: fluids exert pressure on base as well as on walls of container. Pressure exerted in any confined mass of fluid is transmitted undiminished in all direction. Again, pressure exerted in any confined mass, that is any certain mass of fluid, is transmitted undiminished in all direction, which means this pressure, this force is equal in all part of body, equal in all direction. For example, if I have this container that is filled with water, this water will exert same force on this whole wall. That cannot possible that in half of side water will apply more force, and this half of side it will apply less force. That's why we have sentence here: pressure exerted in any confined mass of fluid is transmitted undiminished in all direction, that is same in all direction. Now we have important concept called buoyancy. We have some question that can reveal concept of buoyancy. Have you ever had a swim in a pool and felt lighter? Yes, we know that in water we feel lighter. Have you ever drawn water from well and felt that the bucket of water is heavier outside compared to inside? Yes. Have you ever wondered why a ship made up of steel and iron does not sink in a seawater, but whether the same amount of iron and steel in form of sheet would sink? So we know that we have a huge ship that is made up of steel and other alloys. Due to its particular kind of shape, it can float on water. While if we take same amount of same weight or mass of steel and made up in another shape, it will be sink in water. This question can be answered by thinking buoyancy in consideration. We can reveal the answer of this question by concept called buoyancy. Let's understand the meaning of buoyancy by an activity. Let's take activity 10.4. We have empty bottle. We close the mouth of bottle and try to push this bottle in bucket. Push the bottle into a water. You feel upward force, that is pushing our hand. Try to push it further down. You will find that it is difficult to push deeper and deeper. This indicates that the water exerts force on bottle in the upward direction. If I take this empty bottle and try to push this in water filled of bucket, what will happen? The water will exert upward force in this bottle, and this force on this bottle will transfer to my hand and I can feel upward force. So there is some force which is exerted by water on this bottle in upward direction. Now at some depth we release the bottle. What will happen? It bounce back to surface. It will bounce back to surface. Does the force due to the gravitational attraction of earth act on this bottle? What do you think? Gravitational force is there? Yes, gravitational force is also there. In this position also, Earth will try to attract this bottle, but the force that is act upward by the water on this bottle will be larger than this gravitational force. That's why this bottle will be bounced back on the surface of water. So I hope you can understand there is some force which is exerted by fluid on object. So we take we take this example, and by that we we try to understand what is buoyancy in next lecture. So I hope you understand the concept and points we discussed in this lecture. Thank you.